Welcome back to The Explainer. Today, we are completely dismantling the legacy software development lifecycle and looking right under the hood of DevOps architecture. If you've ever had to deal with agonizingly delayed deployments, broken code in production, or those endless toxic blame games between your teams, you are definitely in the right place. We're going to see exactly how elite organizations have solved these exact problems through aggressive automation and a massive cultural realignment. Okay, let's dive into this.
Here's our roadmap for today. First, we'll map out the traditional software bottleneck. Next up, Agile and DevOps evolution. Then we hit core practices, CI and CD, followed by continuous monitoring and telemetry. Finally, we'll cover transforming teams and operations and wrap it all up with ecosystem and operational benefits. Let's get right to it.
Section 1, the traditional software bottleneck. All right, think about the traditional setup. There is this fundamental, almost baked-in architectural conflict, right? Tasks are totally siloed by strict specialization. On one side, you've got developers. Their entire metric for success is creating software, pushing out new features, basically driving change. But then, on the flip side, you have IT operations. Their main job is managing hardware and, above all else, maintaining system stability and uptime. So you've got one group that's literally incentivized to push change and another group incentivized to prevent it. It's a classic standoff.
And what does that standoff create? The infamous wall of confusion. Developers write their code, and then they figuratively, and sometimes it feels like literally, just toss it over this wall to operations to deploy. Naturally, these manual handoffs lead to massive delays, inconsistencies, and inaccuracies. And when a big batch release fails, and let's be real, they fail all the time, the toxic blame game kicks off. Devs are like, well, it worked on my machine, while ops points the finger right back at the faulty code. It's just a completely inefficient system operating in isolated silos.
Moving on to Section 2, Agile and DevOps evolution.
Now, before we even think about touching the technology, we have to talk Agile. Agile methodologies are what originally broke those monolithic projects down into adaptive, short-term iterations. But here's the secret. Fixing these legacy bottlenecks, it's fundamentally a cultural shift. In fact, it is 80% about the people. You absolutely need cross-functional teams, open workspaces, and shared goals. The process part, that's about 15%. And the tools or products, just 5%. The technology is totally secondary to the human element here.
So how do we actually define DevOps? Well, first off, it's not a standalone piece of software you can just buy off a shelf. And it's certainly not a solitary job title. It's really a philosophy. At its core, DevOps is the union of people, process, and products to enable the continuous delivery of value to your end users. It completely obliterates those siloed dev and ops teams we just talked about. Instead, it merges them into multidisciplinary units that share the responsibility and rely heavily on aggressive operational automation. And that culture builds directly into the famous DevOps infinity loop. Notice how there's no real beginning or end here. It's a continuous life cycle. It shows exactly how those multidisciplinary teams operate in total sync. We flow seamlessly from planning and coding, straight into building and testing, and then right through to release, deployment, operation, and monitoring. And then, that monitoring feeds right back into planning. It's this unbreakable chain of shared responsibility. Which brings us to Section 3, core practices, CI and CD. Okay, let's look at the engine actually powering that loop, starting with continuous integration, or CI. With CI, developers are constantly merging their code into a central repository. The absolute genius of this is that every single code commit automatically triggers builds and tests. This fundamentally shifts left your quality assurance. By catching defects incredibly early in the development cycle, your teams aren't wasting days fighting complex merge conflicts right before a major release. Once you've got continuous integration humming along, you extend it with continuous delivery, or CD, to create a fully automated pipeline. Think about the exact flow. A code commit triggers an automated build, which triggers an automated test, which preps it for deployment. Continuous delivery basically guarantees that your developers always, at all times, have a deployment-ready artifact that has passed standardized testing. No exceptions. When you actually watch this pipeline run, you see code moving sequentially, from dev to QA to staging and finally to production. We call this managing the blast radius. Because the pipeline is hardened by smaller batches and massive automation, you have total control over where code executes. If a nasty bug slips through the CI build, it gets caught in QA or staging long before it ever has a chance to impact your end users over in production.
Section 4, Continuous Monitoring and Telemetry.
Listen, elite performers absolutely do not rely on guesswork. They rely on deep telemetry. Continuous monitoring uses operational dashboards to give teams real-time, granular data about an application's performance and usage patterns. And remember that infinity loop? This telemetry is exactly what feeds back into the planning stage. It lets architects make actual data-driven decisions for the next iteration, spot incidents instantly, and squash bugs before they snowball.
Next up, Section 5, Transforming Teams and Operations. Now, dismantling decades of legacy IT rules, that's going to cause some serious friction. But this brings us to one of my absolute favorite and totally counterintuitive core philosophies of DevOps. If it hurts, do it more often. Seriously, if deploying your software is this fragile, weekend-ruining nightmare, the answer is not to deploy less often. By cranking up your batch frequency, you actually force your system architects to confront that deployment pain head-on. You effectively force the automation of those terrible manual processes.
Think of adopting DevOps like going to the gym for the first time. It is absolutely going to hurt at first, but the more you exercise those new practices, the easier they get. Just like physical cross-training, where you work the largest muscle groups first, you should tackle your most painful, high-impact deployment practices right out of the gate. That's how you build the operational muscle you're going to need for future synergy. To pull this transformation off properly, organizations need to create dedicated transformation teams. And you can't just pick anybody. These teams have to be made up of well-respected staff known for their innovation. Crucially, you have to pull them completely out of day-to-day operational work so they can focus 100% strictly on the transformation. Give them very specific SMART goals, like reduce bug fix time by 60%. Oh, and if you need to, bring in external technical experts or agile coaches to fill in any knowledge gaps.
Finally, Section 6, Ecosystem and Operational Benefits.
Okay, so earlier we established that tools are only 5% of the equation. True, but you still need them to achieve that aggressive automation. To get full lifecycle automation, you have to chain discrete tools together. You're going to need version control systems like Git for the code. You need CI/CD automation platforms like Jenkins or Azure DevOps pipelines. You'll want configuration management tools like Chef, Puppet, or Ansible to handle your deployments. And you definitely need monitoring tools like Prometheus and Grafana for that real-time telemetry we talked about. When you step back and look at the sheer scale of the technical roadmap required for a modern DevOps engineer, it is pretty wild. A competent engineer is navigating everything from basic server admin and scripting all the way down through infrastructure as code, container orchestration platforms like Docker and Kubernetes, and right up to cloud provisioning on AWS or Azure. It's a highly specialized role dedicated entirely to automating software delivery and monitoring the entire IT infrastructure. So why go through all this effort? The empirical DORA metrics absolutely validate the ROI here. We are talking about elite performers achieving 208 times more frequent deployments, lead times from commit to deploy that are 106 times faster, a change failure rate that is 7 times lower, and when things inevitably do break, these teams recover 2,604 times faster. The data is just undeniable. Speed, rapid delivery, reliability, security, they all go through the roof. We've covered a ton of ground in this explainer today, from tearing down that massive wall of confusion to architecting slick, fully automated CI/CD pipelines. So I want to leave you with one final critical question to audit your own systems. Are your current infrastructure deployments a bottleneck, or are they a competitive operational advantage? Because if they're a bottleneck, it is definitely time to start automating away those manual handoffs. Thanks for joining me on this deep dive into DevOps architecture. Keep automating, and I'll catch you in the next one.